Hello everyone. Hello, good evening Dheeraj. Hello Malik. Good evening Aisha. Good evening, good evening. Welcome to day 3 of hello. I guess now I'm audible, right? Uh, yeah. So if you guys have any doubt in the previous session, you can mention it here. So in the previous session, we did one. Okay. So we did one prefix, longest common prefix problem. Does anyone have any doubt in that? First, let's just entertain any doubt and then we will move on to the next problem of try. Okay, Dheeraj, no doubt. Got it. Sanika says explain again. Uh, okay, so let me just see the problem we should discuss. Vishwaraj, I gave some examples in the first session. For you, I can repeat them. Like the first example is the obvious one, Google search. Basically, you write anything and it basically gives you some recommendation based on those are the recommendation which contain your typed search as a prefix, right? For example, uh, For example, like this. I think we talked about it uh, somewhere. We did talk about it. Okay, we can talk about it here. Let's say if I write, then Google might give me some, right. Google search tries to give you, this is my search, and this is what like Google kind of recommends you, right? So this is one obvious, this is one obvious application. Let me just open the chat. Hmm, um, Okay, so we were doing longest common prefix in the previous class. I guess someone has doubt in that. So basically, you are given three words or n number of words. You just have to return the longest common prefix. I guess it's self-explanatory. What does longest common prefix mean? We all know what's a prefix. I hope we all know that in flower, F is a prefix. F, FL, FLO, FLOW, FLOWE, and FLOWER. These are the prefix of flower, right? So we have to return. So we have to return the longest common prefix. Okay. Yeah. And the way of doing that is we simply store this in a trie, and from there we are just trying to like see the longest common branch, because ideally that will be the longest common prefix, right? Because after that the tree diverges, which means there has to be some word which differs from the coming prefix, right? That was the logic of finding this, and now it's pure implementation, right? We figured out the approach, we know what we need to return, and now it's all about returning this. Now it's all about implementation, right? That can be done easily. And we did that using try. Obviously, here was the code. Like this was our node, this was the node, and this was the try data structure. We needed one insert. We just needed to code an insert function and just a helper function which does this longest common prefix. We could have like return is as longest common prefix. Yeah, yeah, and we just code our solution, right? So today's problem which we are going to solve is this one. Design and add and search words data structure. So does anyone have any idea how we can solve this? Hello Mohammed, hello. So let's focus on the today's problem, right? Uh, so one approach that we figured out in the last session was we can do one thing, right? We can simply call a recursion 26 times. There is no harm in that, right? It's problem number 211, Praveen. I think if there is some issue in seeing the problem, is there an issue? Just give me a second. It's working fine for me, Praveen. I guess there's some network issue. Yes, Kirthana, it works. Insert the words as they are coming, and the search function can simply be a like a recursive DFS. Okay, okay, Riddhi. I think yes, the screen is clear. Yes. So one way. So I think by now, and you guys should code it with me. Okay, like code it with me so that whenever you feel like, oh, how is that done? What was the logic behind it? Because it's already been 2 days since we have talked about the logic of try. I know it's not so straightforward, so you will most of you are still confused. You just don't know those gray areas yet. So try to code the problem with me, and then you will realize, okay, I have not understood this. So then I can explain it in the session itself, right? Don't take any doubt from this session. Okay, so okay, so we have to implement two functionalities. One functionality is add word. The second functionality is search. Search would have been simpler if this line would not have been written. Word may contain dot where dot can be matched with any letter. If if this line would not have been there, then it's simply a try, which we coded, right? Recall that we coded three functions: search, insert word, and starts with. Starts with was for prefix. Uh, contains word was for if the whole word is there in the try, and insert was simply to insert the word. So this line kind of differs this problem from the problem of implementation of try, right? Uh, there was another problem. You guys must know that you guys must recall that we did a problem which contained implementation of try. Okay, so how are we going to solve it? Let's see. I hope the writing tablet is visible to all. So this question is, so what we need to take care of: add and search. And in search, one thing is kind of new, that dot matches with every character. Okay. Okay, so one thing which we can do is we can simply like create a try like we do always. Like for example, there is an example of bad, mad, sad, and dad. Okay, so D M S and D. This is how the try will be formed, right? This will be the try structure which will be formed. Does anyone agree? Does everyone agree with what I'm trying to say? And how will this actually be formed? So let's try and visualize this stuff. Okay, so think about this, how this is going to be formed. So it's BMS, it's D, B, M, and S, all connecting with A. Okay, all of them are connected with A. Okay. And this is connected to D. Like this is how it forms, right? You have a 26 cross 26 array. This is what we are doing, right? 26 cross 26 array. Every array contains an address to the next pointer. This will contain address of A. This will contain the address of A. This will contain the address of A. They will all point towards A. And now A will point towards D, right? I hope it's clear, right? Now think about this. We can simply, if we can simply run a DFS, right? in order to search. It's such a beautiful data structure. We just kind of created a graph out of nothing, right? So this is the way to store the words. I'm just diving deep into how we are storing the words because all the algorithms kind of, it's easy to apply, try, right? The tough part is to code it, to understand how we are storing stuff. So this is actually the visualization how it is getting stored. For now, we have taken just three words. For example, let's say I would have taken, let's say there was another word, sit. Okay. Then let's just D, let's put D here, and there is T. It would have been like this. And for sit, the kind of formed like this. Like this, we can add edges, right? Okay. Just give me a second. So no sound. There must be sound. How is no sound an issue? No sound. There must. Uh, okay, sound is there. I guess you are able to. Okay, got it. Um, yeah. Um, yeah. I just lost the track of what I was saying. So 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 you can see we can simply add another word in this. Okay. Let's say there was another word. There was up in this try. In this try, there was a word known as up. So we can simply add it, right? We can create an edge like this. So you can see how beautifully it coordinates, right? Okay. And the search function will somehow like this. For example, I have to search for bat. Okay. Then I go to B. I see B is connected to A. Okay. Then I go to A and then I see what is A connected to. A is only connected to D. Okay. Then bat is not there. Let's say if it was B dot D. Okay. I will go to B. Now the other one is a dot. Okay. Now this is critical. For a dot, we will check the whole array. We will check the whole array and go to every possibility. Right. For example, if this B would have been connected to E and then to G, then for B dot D, we will go to A also and then E also, because it is we are processing a dot and a dot can be matched to every character, right? Understood? A dot can be matched to every character. So whenever we encounter a dot, we will traverse the whole array, and if it's a single character, then we will simply traverse that character and move ahead, right? And at any point, if let's say I have a character A and let's say it's B D D, and I go from B and now I jump on to A. A is not equal to D, then I break. I don't break. It's like I return false. I return from that branch. right? But whenever like there is a dot and D, for example, I'm just writing for the understanding. Let's say there was a word BEG. Okay. So, and if I'm getting B dot D, then there can be a case where we first go to E, and then we see, okay, BEG does not match. BED would have matched because dot can be matched to any character. But now we encounter G, we return false. We return false. We again go to B, and again now we go to A. Okay, A matches, and now we go to D. Okay, D also matches. So then we return from this branch, we return true, right? Okay, so Dheeraj, what I'm saying is, for a character, you only need to check the character, right? Let's say I have BAD, bad. I simply go to B, I go to A, I go to D. If I have BDA, then I go to B, I see B is only connected to A, only connected to A, and A is not equal to D. So I return false. Okay. But however, if this would have been B dot D, then for a dot I traverse the whole array. Because there is a possibility this dot can match to every character, right? This dot can match to every character. Every 26 possibilities are possible in this dot, right? And I will go to every such alphabet which is not null. What does that mean? If it is not null, this means it has some address. If it has some address, this means it is connected to B, right? Exactly. So let's try to code our solution, and then it will be easier for us to understand this DFS part. Okay, so I have already written the part of the node. I think we have written this node a lot of times, and I have also written this add word function. It's exactly same as in the tries. I have just copy pasted it. Okay. Okay, let me just give you guys some time to code it yourself. Okay. In the meantime, I will give you time to mark your attendance, but just give me a second. Okay, so I have posted the attendance link in the chat. Uh, yes, Athar, you are right. I should pin it, but I don't know how to pin a comment. So my bad. I guess we can do it if we are operating the stream directly from the YouTube. But in this case, I am operating it from StreamYard. So I guess that's the issue. I mean, it can also be a skill issue on my side. I I don't know how to. I'm new to streaming. No, Monica, we will just be solving problems. They are not assignment or projects in DSA Bootcamp. DSA Bootcamp is purely based on like Komal. My name is Maulik. DP problems. Surname. I think in the starting of June or towards the no, not the starting of June. Towards the end of May, I guess 20th May, we took a graph and DP bootcamp. It's fine if you didn't attend it, but try to see one video where we started with DP. There uh, uh, I have discussed some of the approaches which might help you. Okay, I think everyone has uh, marked the attendance, so I think we shall continue. Right? It's fine. I will post the link again. You can mark on this link. I've posted the link in the chat again. You guys can mark the attendance. Not sure, Gaurav. Not sure. It's all on the management what they decide. My work is just to teach. Okay, so let's just come back. So as we discussed, I have just copy pasted this code of add and this code of a node, right? Now search. This is critical. Okay, this is indeed a bit critical. So we can simply create a helper function. Int I node star node and string word. This is all we need. And simple return help 0 comma word comma root. Actually, just create a node which is root. And now new. Okay, return true. Okay, now it's critical. If word I not equal to dot, then if node contain key function contains key, okay, contains key word I, then return help I plus one word node get word I. else simply return false. Now if word I equal to dot, okay, now we need to check bool possible, we'll keep it false. For character I equal to a, I less than equal to z, and I plus plus. Now you check for every character, right? Because dot can match with every character. Now if, and now we do or, right? Because if any one possibility is true, we need to return true, right? So one of the possible, if any one of the possibility is true, then it's good for us. So we do or help of I plus one word move get I return possible. Okay, I guess this should work. Okay, the runtime error. The worst error. Out of bound error. How is out of bound error coming? Okay, is there something we are doing which we shouldn't? Okay, if I simply return true here, I just want to check where the error is coming. If the error is coming at search, then all the test cases should pass. Okay, so the error is coming in the search function. Okay, what's the problem in the search function? Uh, okay, okay, there can be a case. There can be a case where huh, not sure where is the error coming. Add word. At which search is it coming? This is what I'm trying to fix. You just need this. This one. Just searching for crowd. Okay, it works. Does it work? It also works. I guess our logic is failing in the cases where dot appears. I have like tested. It is working for the other words, not working for the words where dot is appearing. Yeah. So what's the issue? Let's quickly see the issue. If word I not equal to okay. If word I not equal to dot. If it is equal to dot, if it is equal to dot, then we go here. Yes. Link ch minus 8 is showing out of bounds. Why is it showing out of bounds? I want to print I every time. Yes. What can be the issue? This should be the solution. I'm not able to figure out the error as of now. The error. Oops. Okay. They're using the same variable. We should be using J where yes, it should work. Yep, it should be. I hope it will. Yep, it will. Okay. So we add A, we add AB. Search for A, giving true. Search for A dot, giving false. Okay. Okay, so this is the code. I will try to see if there is any error in this. But I hope you guys see the core concept, right? I hope you guys understand the core concept behind what we are trying to do. We're calling DFS. Okay, point. Need to debug this as of now. What can be the issue? A, B. Oops, this is the issue. Yes, now this should work. Come on. Output true, but it's false. Okay. At and 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 now search for A. Okay. Yes, it works. Such a long wait to see this accepted. Okay, so the issue was that we also need to check if it's the whole word, if the word ends at this point, right? This is what we were failing at. Now it works. Yeah. So about the notes, I will try to provide this code today itself. I have found a way after researching a lot today. I will try to share a PDF which will contain all the notes, all the codes. Notes I've been sharing. The codes were the issue. I will share the code. So yeah. Yes. I hope you guys like today's session. Tomorrow we are going to talk a bit. We have been doing strings a lot in tries, right? Tomorrow we'll talk about how we can use tries in the problems which involve bit manipulation. We'll try to do some 2 3 problems which include bit manipulation using tries. It's kind of the same structure, right? If there is an int can contain 32 bits. An alphabet, if we are given its lowercase, it can contain 26 alphabets. Can you understand? Are you able to understand there will be a same type of structure like this type of structure? Like here we have 22, 26. They in bit manipulation it will be 32. As simple as that, right? So yes, I hope you guys like today's session. Now we will meet tomorrow at the same time for the last day of the session. This is a 4-day boot camp. Remember that. So tomorrow we'll be talking about little tough problems. Like this was also a tough problem, but using try in bit manipulation problem is considered the toughest type of problems because they are not easy to get. That try is being used in this problem, right? So tomorrow is going to be a very important day. So yes, um, see you guys tomorrow. Okay, bye bye.